Hi all, good morning, good evening. My name is Venkatesan. I'm working as a senior technical manager in HCL Tech. Today I'm going to discuss about operationalizing predictive analytics in education by combining MLOps DevOps strategies for scalable ethical student success. So first, what is predictive analytics? So predicting unknown future by using techniques like data mining, machine learning, by analyzing the current data to predict the future outcome. So MLOps is a discipline that applies DevOps principles in the machine learning lifecycle. So we can see this in this session. So the educational data challenge opportunity. So digital learning platforms not only generates grade and attendance and also generate huge volumes of behavioral performance and engagement data. So always raw data does not deliver any meaningful sites if we harness it well. So this data can help us to predict challenges early and also improve student success at scale. So the reality, educational institutions struggle to transform predictive models into reliable production-ready systems. There's a gap between experimental insights and operational deployment, which requires robust DevOps and MLOps practices. So there are some advantages of MLOps. So the MLOps brings reproducibility, so we can test the results of our model, and then it also brings scalability and monitoring and governance. So from experimentation to operational impact. So experimental models is happening in the development phase, like proof of concept analytics in the notebooks and sandboxed environments. So in production systems, the models can be scalable for a huge volume of data and can be monitored and governed by ML pipelines integrated with the different educational workflows. And some of the measurable outcomes are improved student retention rate, engagement, and student success at scale. So this session bridges the gap between data science experimentation and DevOps driven production deployment. So the machine learning toolkit for education. There are many models available to make predictions in education domain. So here I highlighted some of the key models. The first one is binary classification. So binary classification is a supervised learning technique. It's used to predict categorical outcomes like pass or fail, at risk or not at risk. So in those scenarios. So logistic regression is a statistical model used to predict probability outcomes of unknown patterns by using input factors. So logistic regression can be used for pass-fail predictions of the students. The next one is ensemble methods. So random forest and gradient boosting are high performance models. So the random forest models make predictions by combining the results of many individual trees. So here the prediction is by averaging for regression models and by majority vote for classification models. So the goal is to reduce the variance, which is overfitting, and the gradient boosting make predictions by combining many weaker models in a sequential way. So here the final predictions is by the sum of all the trees. So the goal is to reduce bias, which is underfitting. So the next one is networks, which is time dependent model. So long short term memory and recurrent neural network architectures capture temporal learning patterns. So this model can be used for semester performance trajectories of the students. See, advanced analytical approaches. So unsupervised learning. So in unsupervised learning, usually we don't have any specific target for predictions, but the grouping and clustering techniques reveal any new or complex patterns. There are a couple of key techniques, k-means and hierarchical methods. So the k-means is used to group students in a cluster by similarity levels, and the hierarchical methods is used to group students at different similarity levels. So basically it's a nested tree. So natural language processing is used for sentiment analysis pipelines. So in natural language process, the unstructured data is transformed into structured format to make some decisions. And performance forecasting. So gradient boosting models predict final outcomes early in the term. So here we can see some of the critical factors determining predictive accuracy. So the first one is data quality and completeness. So during any pre-processing steps, if we see numeric missing values, we can impute with mean values, and any categorical values can be labeled with unknown. And also there is some normalization techniques to format the data consistent across records. Some of the techniques are 0 to 1 transforms, Z transforms, and log transforms. The next one is future relevance and engineering. See, raw data, transform raw data into meaningful features. So those features is very useful to make accurate predictions. So temporal considerations, so it's for time-based data. So the timeline-based data should be lined properly in the right order with the right timings. The next one is sample size and class balance. So sample size refers to the data points required to train the model. So always the large samples give reliable patterns and higher accuracy, and smaller samples increase noise and overfitting. So the next one is model complexity and interpretability. High complex models can capture reliable patterns and also achieve higher accuracy. And the interpretability is the key in the educational domain, which shows the relationship between input and output. Here we can see the evaluation metrics for educational predictive models. So selecting the right metrics is crucial for validating any predictive models. So here we can see the classification materials is used to evaluate the classification models. So here the confusion matrix shows how well the classification model performs by comparing actual and rectal labels. So these 4 labels are created from the confusion matrix. This is the foundation to evaluate any classification materials listed here: accuracy, precision, recall, F1 score, ROC, and AOC. So here we can see some of the metrics used to evaluate regression models. So this metrics is used to measure how well a model predicts continuous value and also how close predictions are to actual outcomes. Some of the metrics are mean squared error, root mean squared error, and coefficient of determination. So here we can see DevOps foundations for machine learning success. So any machine learning systems deliver real value when they are built on strong DevOps principles. So the first principle is data versioning. So here the data set, so there is used to track data set lineage and any schema changes and any transformations. So the tools like DVC, data version control, which is similar to Git for ML and data pipelines. It's used to version data sets and also is used to track any changes in data, features, and models. The ML flow is the machine learning lifecycle flow to track, package, and deploy models. Next one is future engineering pipelines. So here, this is used, the future logic. This is here is to ensure the future logic is consistent between training and inference environments. The next one is CI/CD pipeline for machine learning is used to implement automated testing, validation, and deployment workflows. Next one is model monitoring. If any model is deployed in production environment, so that should be continuously monitored to track prediction latency, data quality, and directions. So here we can see the typical MLOps DevOps pipeline architecture. So there are 6 different core layers of this architecture. So the first one is data management. So this layer ensures the data used in the training and inference environments is properly versioned and validated and also documented. So the next layer is model development. So this is where experimentation happens in a reproducible way, and also model versioning and parameter tunings are happening here. So model deployment. So this is where DevOps meets machine learning. So creating CI/CD pipelines for models and also creating automated testing gates and creating development strategies. And the next layer is model monitoring. This is the most important layer of machine learning. So here we can track performance, drift, fairness, and alerts. The next layer is infrastructure and automation. This is the operational backbone layer. So the containers are used to bundle codes and dependencies and libraries. And then the orchestration process is used to automate model deployments and auto scaling and load balancing processes. So governance and compliance is the key in educational any other regulated domains. So to implement privacy and audit processes. So that's all about this architecture. So here we can see some of the infrastructure key points that show scalable and reliable ML systems. The first one is performance. So any high performance models and real-time inference systems usually require more GPUs or auto scaling services compared to batch pipelines. So the next one is cost efficiency. The cost efficiency is about delivering impact without overspending on any compute services. So in this case, less and spot instances are good considerations. And reliability. Student-facing systems require high availability, and any failure in the system should be up and operating quickly. So detecting and managing model drift. So why drift matters in education? So usually the models are trained on historical data. So whenever any new data arrives in the production environment, the model performs poorly. So drift detection systems are used to compare statistical properties of training data against production inference. So if there is any deviation, it is flagged before it impacts any production quality. So governance. So always fairness, transparency, and privacy are essential because they ensure our systems treat equally everyone. So the first one is fairness. Validate model across different subgroups and also implement bias mitigation techniques. The next one is transparency. So transparency is to show how our model works and also show how and why prediction occurs so that the stakeholders can understand it and trust the decisions. So we can deploy explainable AI techniques like SHAP and LIME. So the next one is privacy, is to implement secure and restricted role-based access controls to comply with FERFA. So FERFA is a federal law that protects the privacy of the student records and GDPR rights for European Union. So auditability and responsible deployment. So model cards are used to document how the models build and then on what is the intended use of the models. So we can document those information in the model cards. So for auditability, model cards is the backbone. And automated validation is used to verify fairness, privacy, and the performance before production and deployment. So the next one is human in the loop. So human in the loop is also in the design approach where human remains actively the key points in any machine learning and AI decisions. Audit trails are to log predictions, versions, and outcomes for audits and compliance. So the final step is integration with student support services. So real-time decision support. So any prediction output flow must be integrated with management platforms and the dashboards. So for this, the API-driven architecture can be implemented to integrate data from models output to the dashboards. Actionable alerts. So transfer model outputs into task list for advisors, tutors, and support for decision making. Continuous feedback on model evolution. So this is the standard steps in any of the software development lifecycle. So the first one is deploy, monitor, collect feedback, and the last step is iterate. So retrain models with updated data and updated features with improved architectures. So production ML systems are never finished. Continuous improvement loops ensures model remains effective. Practical guidance for implementation. Always start with clear use cases, define specific intervention workflows and success metrics before building models. Building cross-functional teams. Combine data scientists, DevOps engineers, domain experts, and compliance officers. Invest in infrastructure early, MLOps tooling, monitoring platforms, and governance frameworks. Prioritize ethical considerations, fairness, transparency, and privacy. Delivering scalable, ethical, impact-driven analytics See, at the end, operationalizing predictive analytics in education is by combining strong MLOps practices with ethical governance so that institutions can deploy the models that are scalable and trustworthy. So this approach measurably improves student retention rate, engagement success, and success at institution level. So that's all about this session. So if required, we can collaborate together to build analytics system in the educational domain by combining machine learning and strong DevOps principles. Thank you.